Welcome friends. So let us continue our discussion on two-port network with further topics. So far we have discussed the definition of different parameters. Also we have established the interrelationship between any two parameters, and we have seen what is a reciprocal network and what is a symmetrical network, and their representation in terms of each parameter. Now in this part we shall try to solve some numerical problems with various kinds. So let us continue. So consider figure 11. We have a network with a dependent source. We have a network with a dependent source of voltage 2V1. Sorry, it is not a voltage source, it's a current source of magnitude 2V1. So it's a current voltage dependent current source 2V1 magnitude. So now you need to evaluate Z parameter. You need to evaluate Z parameter of the network shown in figure 11. So we have our fundamental equation as V1 is equal to Z11I1 plus Z12I2, V2 is equal to Z21I1 plus Z22I2. So let us solve one by one. Let us say we are making open circuit output port, right? The first step, let us make our output port open circuit. So we have I2 is equal to 0. We are having I2 is equal to 0. So now let us analyze this circuit very carefully. Let us start from the primary side. We have a voltage source V1. And this voltage source effectively falling directly on this 1 ohm resistor, directly falling on this 1 ohm resistor. So you can write current flowing through this 1 ohm resistance is V1, because it is V1 by 1. So it will be something directly you can write V1. So remaining current, which is you see the input current is I1. So the current flowing through this 1 ohm resistance is V1. So the remaining current, which is I1 minus V1, this amount of current is flowing through this 1 ohm resistor. This is connected between X and Y. Okay. So after reaching at node Y, see one current is flowing to V1. Okay. And the remaining current will be flowing through YZ. And since this is open circuited, so the whatever current is flowing through YZ, that will be flowing through this 2 ohm resistor. Now the output port is V2, that is the voltage across the output port is V2. So the current flowing through this 2 ohm resistance is V2 by 2. So this current actually V2 by 2, because voltage appearing across this 2 ohm resistance is V2 and current flowing through the 2 ohm resistance is V2 by 2. And due to the same reason IYZ, so this current should also be V2 by 2. This current should also be V2 by 2. So what will be IXY? So the current flowing through IXY is nothing but 2V1 plus V2 by 2. Why? Because why this is so? Because you see this current, whatever I am mentioning it as I1 minus V1, which is IXY, right? So that IXY is the entering at node Y. So from node Y there are two currents are leaving. One current is 2V1 and another current is this V2 by 2. So IXY is equal to 2V1 plus V2 by 2. Okay, 2V1 plus V2 by 2. So again at node X, if you calculate or if you apply KCL, so at node X you can write I1 as the entering current, this current. So those two, what are the leaving currents? One current is IXY, and another current should be this current V1. So if you put, so now if you come to this equation, you can understand what is I1. I1 is equal to V1 by 1, which is this. And what is IXY? IXY is 2V1 plus V2 by 2. 2V1 plus V2 by 2. This is this. So if you add them, you will get it is 3V1 plus V2 by 2. So this is equation 1 for you. Again, now if you want to apply KVL, on the loop, right? If you want to apply KVL, so this is the input voltage V1, right? This is the input voltage V1. Now a drop is coming across 1 ohm. What is that drop? That current flowing through this 1 ohm resistance, which is this 2V1 plus V2 by 2 into 1. So which is written in this term 1 into 2V1 plus V2 by 2, that is the voltage drop across 1 ohm resistor. Then voltage drop across this 2 ohm resistor, which is 2 into IYZ. 2 into IYZ. What is YIZ? So it will be V2 by 2. So it is written this by this term 2 into V2 by 2. Okay. And finally we have got this voltage, which is V2, that is open circuit voltage. Okay. So I am writing again V1, that is the input voltage. Now what is the voltage drop across 1 ohm resistance? It should be 1 into 2V1 plus V2 by 2 plus what is the voltage drop across this 2 ohm resistance? It will be 2 into current flowing through that 2 ohm resistance, which is V2 by 2. And finally we have this open circuit voltage V2, which is directly falling on this 2 ohm resistance, so V2. So if you solve this, you will get a relationship V1 is equal to minus 5 V2 by 2. So from equation 1 and 2, you can write, if you solve, I1 is equal to 7 V2, right? So if you carefully look the equation, so from these two equations, you can directly write Z21 is equal to V2 by I1 with, of course, I2 is equal to 0. So if in this way, if you solve, you will get our first parameter is equal to 1 by 7 ohm. Okay, this is our first parameter, which is 1 by 7 ohm. And similarly, now if you continue our analysis, again from this equation 1 and 2. So now if you substitute or if you establish a relationship between I1 and V1, you will get I1 is equal to 14 by 5 V1. So from there you can get your second relation, Z11 is equal to V1 by I1, which is equal to 5 by 14. Okay, so we have solved two parameters. Now we will do the reverse thing. We will do the reverse way. So now in this way we are giving supply at the V2 at the output port V2 and current is I2 flowing into the network, that means into the Z node. And we are making this side open circuited, that means I1 is equal to 0 and V1 is something. Some V1 has some value. Now, if you now analyze this circuit, this 1 ohm resistance, you see this current should be V1 by 1. Why? Because this voltage is V1 which is directly falling on this 1 ohm resistance. So this current should be voltage by resistance. So V1 by 1 is equal to V1. So as a result, since this side is open circuited, so no current should be flowing through this side. So this V1 by 1 current should be flowing through this 1 ohm as well. So this is also V1 by 1. So now if you apply KCL at node Y, so we can write IZY. We can write IZY, that means current flowing through this 2 ohm resistance, this current. So which is equal to, you see there are two currents outgoing. So one current is V1 by 1 and another current should be 2V1, which is this dependent current. So that is okay. Again, if you apply KCL at node Z, that means at this node, you see at this node this I2 current is entering. So we are writing I2. Now what is IZY? IZY is this current V1 plus 2V1, which is 3V1. And what is this current? Actually, current flowing through this 2 ohm resistance, it is actually V2 by 2. It is actually V2 by 2. Why? Because this voltage V2 is directly falling on 2 ohm resistance. So this current should be V2 by 2. So I2 should be is equal to 3V1 plus V2 by 2. So that is the equation. I2 should be is equal to 3V1 plus V2 by 2. Again, now if you apply KVL, now V2 which is equal to, right? Now what is this voltage? That means VZY, it is 2 into this current IZY. What is IZY? IZY is equal to 3V1. IZY is equal to 3V1, right? So it is 2 into 3Vy. That is the thing. It is written plus 1 into V1. This voltage drop. That means current flowing through this 1 ohm resistance is V1. So voltage drop is V1 into 1. Okay. Plus this voltage. So altogether we are getting, I am writing again. So V2 is the input voltage. So this voltage drop is 2 into 3V1 plus voltage drop across this 1 ohm resistance is 1 into V1. And finally we have got this voltage appearing across this 1 ohm resistance as full. So we are getting V2 is equal to 8V1. 8V1. So now if you substitute I2 is equal to 3V1 plus V2 by 2. So if you substitute V2 is equal to 8V1 in this expression, so you will get Z12 should be V1 by I2 is equal to 1 by 7 ohm and Z22 is equal to V2 by I2, that will be equal to 8 by 7 ohm. So this is our solution of Z parameters. So how we are getting these values? Simply you from this equation, from this equation 3, which is I2 is equal to 3V1 plus V2 by 2. So if you put V2 is equal to 8V1, so this equation will turns 3V1 plus 8V1 by 2. So it will be I2 is equal to 7V1. So V1 by I2, which is equal to Z12, which is 1 by 7 ohm. And similarly, if you substitute I2 is equal to P into, now what is V1? V1 is equal to V2 by 8. V2 by 8 plus this V2 by 2. So if you solve, it will be 3 plus 4 V2. So it will be 7 V2 by 8. So Z22 is equal to V2 by I2, which is equal to 8 by 7 ohm. So in this way we solve. So ultimately our final answer, if you solve Z parameter, this is the answer for Z parameter. So as it can be seen, it is neither reciprocal nor symmetrical. So let us move to our next problem. Now in this problem stated in figure as shown in figure 12, it is to evaluate H parameters. It is to evaluate H parameters. So these are the fundamental equations of H parameter. Right. So at one point of time you should make V2 is equal to 0. That means output port must be short circuited. And at some point of time you should make I1 is equal to 0. That means input port should be open circuited. So let us first make short circuiting. Let us first make short circuiting. So we are making first V2 equal to 0. Now as we make the output port short circuit, so you see the current becomes negative, I2 becomes minus I2 because current direction changes, right? Current direction changes. So let us analyze the circuit. Let us say we have this node as X. So current entering to the node X is I1, and there are three different currents are leaving. There are three different currents are leaving. Let us mark one by one. The first current is leaving from node X is 0.8 I1. This is the current one. So if you write entering current is I1. So first leaving current is 0.8 I1. Right. Now the next leaving current should be flowing through this 2 ohm resistor. Should be flowing through the 2 ohm resistor, right? Now what is the flowing through the 2 ohm resistors? Okay, let me put it down. I 2 ohm resistor, right? And third current should be flowing through this 1 ohm resistor. Okay. So these three currents are leaving from node X. So 0.8 I1 plus, now what will be the current flowing through these 2 ohm resistors? It should be Vx by 2. It should be Vx by 2. Why? The reason being, you see this is directly short circuited. So see, if this is the ground node, due to the short circuit, this node also be ground node. It is converted to a ground node. So the potential of this node is 0 volt due to of this short circuited of this entire path. So this current is nothing but the potential difference existing is Vx minus 0, which is Vx. What is the resistance? 2 ohm. So this current must be Vx by 2. This current must be Vx by 2. And as per the similar reason, the current flowing through this 1 ohm resistance is nothing but Vx by 1. So if you solve this, you will get 0.2 I1, that will be is equal to 3 Vx by 2. Okay. So that is the exactly it is written here. It is 3 Vx by 2, that will be is equal to 0.2 I1, or 0.2 can be written as I1 by 5. I1 by 5 is equal to 3 Vx by 2. So that is our first equation, which is equation 5. Next, again we can write what is I1. I1 is nothing but, you see, this voltage, this potential is V1, this node, and this is Vx. So it is the potential drop existing between these two nodes is V1 minus Vx, V1 minus Vx. What is the resistance? 1 ohm. So this current should be actually I1. So I1 is equal to V1 minus Vx by 1, which is V1 minus Vx. So with that, you can write Vx is equal to V1 minus I1, which is equation 6. So from equation 6 and 5, you can write 3 by 2. Now in place of Vx, in place of this Vx, you write V1 minus I1, and which is equal to 1 by 5 I1. So if you solve, you will get H11 is equal to V1 by I1 is equal to 17 by 15 ohm. That is our first solution. Which is H11. And similarly, if we proceed, you get one as H21 as I2 by I1, I2 by I1 with, of course, V2 equal to 0. So let us try to find out the relationship between I2 and I1, right? So 0.8 I1 plus Vx by 2 is equal to minus I2. Now what is the reason? Why? So you see this node, actually this node, which is I am referring as 0 voltage node. So at this node, let us say this node is Y, let us say. So at node Y, what is the incoming current? At node Y, incoming current is nothing but 0.8 I1 plus this current Vx by 2. Vx by 2. Right, this is the entering current at node Y. So from node Y, what is the leaving current? Leaving current is minus I2. Leaving current is minus I2. So that must be equal to minus I2. So that is what it is written here. 0.8 I1 plus Vx by 2, which is equal to minus I2. So if you substitute 0.8, that means 4 by 5 I1. Vx is equal to, you know, V1 minus I1 by 2 is equal to minus I2. So if you substitute, V1 is equal to 17 by 15 I1 from this relation V1 by I1. So if you solve, you will get H21, which is I2 by I1 is equal to 13 by 15. That is a unitless. It should not have any unit. So we have solved for two parameters H11 and H21 by making output port short circuited. Now moving on. So let us apply our second process, that is, let us make I1 is equal to 0 by making input port open circuited. So please refer to the figure 12b. Please refer to the figure 12b. So we are making open circuit our input port. So we have a open circuit voltage V1. We should not have any current I1. So I1 should be equal to 0. At the output port we have a voltage V2 and we have a current I2. Now interestingly, if you carefully look, you see in the mother diagram or mother network, refer to figure 12, we have a current source. Magnitude is 0.8 I1. Now at the second step, since we are making I1 is equal to 0, so entirely this current source will go out. Its magnitude will be 0 because we are making I1 is equal to 0. So that is the reason this dependent current source disappears from the network and it is represented as an open circuit. That is the first important observation. Now, due to this disappearing dependent source, now this network looks pretty simple. The network looks pretty simple. So it is basically a T network. Basically a T network. V2, this current is I2 and this is V1. Basically it's the same network. So it will be 2 ohm, 1 ohm, and so no current should not be flowing through this 1 ohm. So entire I2 will be flowing through this. So you can write V2 is equal to 3I2. V2 is equal to 3I2. That is why it is written. So from this expression, if I write it again, hybrid parameter equation, V1 is equal to H11 I1 plus H12 V2 and I2 is equal to H21 I1 and H22 V2. So we are making I1 is equal to 0. So H12 should be is equal to V1 by V2. Okay. And H22 should be is equal to I2 by V2. Of course with I1 is equal to 0, right? Of course with I1 is equal to 0. So since V2 is equal to 3I2, so from this we using definition of H22, so we can write H22 is equal to I2 by V2 is equal to 1 by 3 mho. That is our third parameter. And lastly, we have V1 is equal to I2. Why? Because you see this voltage, whatever is the voltage, what is this voltage? Voltage appearing across 1 ohm. The current flowing is I2 and you see the resistance is 1 ohm. So it is voltage drop is 1 into I2 and which is equal to V1. So this V1 is directly falling on this 1 ohm resistance. That is why it is V1 is equal to I2. V1 is equal to I2. So if you substitute equation 7, so H12 is equal to V1 by V2. So V2 is equal to 3 V1 then, so V1 by V2 will be 1 by 3. It should be unitless. So that is our fourth parameter we have solved. So when you solve the entire H parameter, it looks like this. This is a H parameter. Now moving on to our next problem. Now in this problem it is said or it is asked to obtain Y parameters. So we have a figure 13. Again we have a dependent current source of magnitude 2 V2. So it is a voltage dependent current source. These are the fundamental equations that defines Y parameters. So now, since it is a short circuit parameter, let us first short circuit the output port, right? Let us first short circuited the output port. V2 is equal to 0. So due to this fact, I2, the direction of I2 reverses, that is why it is taken in the negative direction, minus I2. So since V2 is equal to 0, so this current source disappears because its magnitude will be 0. So this is disappears. So it is very straightforward, you know. So what you can write here is that you write the current I1 is flowing through the 2 ohm resistance. So this is the drop, 2I1. Again, this minus I2 will be flowing through this 2 ohm resistance. So it will be 2 into minus I2. So as a result, V1 should be is equal to 2I1 minus 2I2. Now at node X, if you apply KCL, so what is the current entering? Entering current is I1. Okay. Now what is the leaving current? This current must be Vx by 5. This current must be Vx by 5. Why? Because it is a ground node. So the potential existing between X and this ground node is Vx. Resistance is 5 ohm. So the current flowing is Vx by 5. So this is the one leaving current, and by similar measure, this is the another leaving current. By due to this direct short circuit, this node now becomes zero potential node. So this current is nothing but Vx by 2. So you can say that I1 should be equal to Vx by 5 plus Vx by 2. So which is equal to I1 is equal to 7 Vx by 10. Which is equal to 7 by 10. Now what is Vx? So let us find out what is Vx. Now you see, what is I1? What is I1? I1 is equal to nothing but the potential drop existing, that is potential difference is existing, V1 minus Vx, and this 2 ohm resistance that causes the current to flow. That means this I1 must be is equal to V1 minus Vx by 2. So as a result, Vx will be V1 minus 2I2. V1 minus 2I1. So that is written V1 minus 2I1, which is equal to Vx. So I1 is equal to V1 minus Vx by 2. So from there you write Vx is equal to V1 minus 2I1. So if you solve this, you will get this relation. 12 by 5 I1 is equal to 7 by 10 V1. So that immediately follows what is Y11. Y11 is equal to I1 by V1, which is equal to 7 by 24 mho. That is our first parameter, Y11. Okay. So now if you follow the current division rule, so you see this is the current minus I2. So if you recall the current division rule is the total current, which is I1, into resistance of the other branch 5 divided by total resistance, that is 5 plus 2, 7. So minus I2 is equal to I1, 5 I1 by 7, right? So that is the written here, minus I2 is equal to 5 I1 by 7 from the current division rule. So if you substitute 12 by 5 I1, now I1 is substituted 7 I2 by 5, okay, that is equal to 7 by 10 V1. So with this, if you solve, then you will find Y21 is equal to I2 by V1, which is minus 5 by 24 mho. Okay, so that is the half problem is solved. Now let us solve the second part. Now let us make the input port short circuited. Let us make input port short circuited. So we are making V1 is equal to 0. So the direction of I1 is reversed. So it will become minus I1. Now this current source, the dependent current source remains as it is, because V2 is not now 0. It is there, V2, which is injecting some current I2. So let us, let us analyze the circuit. Now with respect to this node X, there are two incoming currents. One current is I2, which is entering to this node X. Another current is 2V2. This is also entering into the node X. And what current is leaving? Minus I1 is leaving. So our first equation is I2 plus 2V2. I2 plus 2V2, that is the entering current. That must be leaving current minus I1. That is our first equation. Now if you solve it for KVL equation. Now what is V2? V2 is equal to, now this I2 is current flowing through the 2 ohm resistance. The potential drop across this 2 ohm resistance is 2I2. This is quite obvious. And the current flowing through this 2 ohm resistance is minus I1. So it will be 2 into minus I1. Okay. So 2I2 remains as it is. Now in place of minus I1, we substitute I2 plus 2V2. So if you substitute and if you solve, it will be V2 is equal to 2I2 plus 4V2. From there, if you solve, simplify, you will get 2I2 is equal to minus 3V2. And from there, you can solve one parameter Y22, which is equal to I2 by V2. That will be is equal to minus 3 by 2 mho. Let us moving. So from equation 10, what we have got? So V2, we have not V2, actually it is I2 plus is equal to minus I1. So now what is I2? I2 is equal to minus 3 by 2 V2. So in place of I2, it is substituted minus 3 V2 by 2. So from here, I2 is equal to minus 3 by 2 V2 plus 2 V2 is equal to minus I1. So if you solve, you will get a relationship between V2 by 2 is equal to minus I1. V2 by 2. So from there, actually. So with this, if you solve I1 by V2, you will get Y12, which is equal to minus 1 by 2 mho. That is our parameter. So in this way, we have solved the entire problem, entire network, and we have solved Y parameters, and we have got this answer, 7 by 24 minus half, minus 5 by 24 and minus 3 by 2. So this is our solution. So with this, we are ending this session here. From the next session, we shall discuss few more problems to demonstrate various concepts on two-port network. Thank you.